if you go back to your Excel file.
Yes.
Yes, so you go from 18808 to 1159. Yes. Yes, so in your case, you have extrapolation. Yes. If you go to home, editing, fill series.
Sorry, because it's set in Italian, my Excel. But
yeah, let me send you a link. There is no you can do have a look on this web page. Yeah, Salvatore, it's recorded right now. Yes, thank you. It's recorded. Yes. Can you have a look on this web page? Read this web page, and then I think the problem that you have is similar to the one that is described in this page. Example 1.
Okay.
Okay, have a look at there, and then hopefully you can follow exactly the same steps.
Okay, thank you very much. And then I should be able to re-enter.
Yes, then you're going to fill the missing cells based on the first and the last observation that is available to you.
Okay.
And then you're going to insert in Gretel again, and then you're going to redo the analysis.
Okay, thank you very much.
Okay. That would be useful for other people as well.
Okay, Professor, I also have a question, please, regarding.
Yes.
Who
is this? Marcus
Geiger.
Sorry?
Marcus, we work on Spain. Marcus Geiger, do you see me?
Yes.
Will you share my screen again?
Let me allow you to share your screen. Okay.
Thank you.
Marcus Geiger, make a presenter.
Okay.
So which country are you working?
Spain.
Spain.
Spain, exactly, yeah. Okay, can you see my Excel?
I can see your Excel screen, yes.
Okay.
Yes, in 1962, there is definitely a problem.
The thing is, we think it's rather the others that are a problem, because we have CO2 emissions per capita, right? And shouldn't they be like, I don't know, if we have 0.85, and then we think that the decimal point is, I don't know, shifted towards after the second digit, So it's 10,325, and we don't know how to get rid of that. So we think it is rather 1.0325.
I'm opening the initial Excel file, which you can download again because I have given you the link. Let me open my Excel file to see. Spain. Okay, so which year you're starting? 19?
We are starting 1850.
And which year you have a problem?
From 1929 on, when there is a 1 involved most of the times, or like
1920.
Exactly 9. And then from 1945 on.
Uh, 1945, I have 1.0513.
Okay, yeah, because we have 10 point.
Well, what I would suggest you do is you delete this Excel file, you go back to the web page, you download the data,
Okay.
you filter the data for Spain.
Yeah.
And because the way you have filtered the data here, it looks problematic. For example, in 1929, you have 10, when the correct number is 1.0325.
Exactly.
So you have the wrong decimal point there. So
Yeah.
go to the web page again, download the Excel file.
Okay.
Filter the data, take the data from Spain only. And this would help you to find the data correctly.
Okay, yeah, we did that several times, and it was always also there was some problem with some data points in the 1980s. We had to manipulate them because there were like long lines of, I don't know, dots.
Can I share my screen so you can have a look?
Thank you.
Can you see my screen? Can you see the file?
Yes, I see everything, yeah.
Okay, so I would filter the Excel file. Okay. And then I would ask, this is the initial Excel file.
Yes.
Which you can find on the web page. And then all I need is Spain.
Yes.
If you have an Italian Excel file with regional settings, this might be the problem, by the way. Okay, so all I need is, so I need GDP per capita and CO2 emissions. So I need these two. Let's say up to 2018. I would copy this. And then I can open a new file. And everything is fine here. You can see there are no problems with the decimal points.
Okay, that's odd.
The one possibility is that you are using an Italian Excel file with regional settings. That could be the problem.
Okay, no, but because actually my partner uses Italian, I'm using the Austrian Excel file, and we have the same problem. So maybe it's both of us. It could be.
Yeah, usually the problem is because of the regional settings. Sometimes the decimal points are not properly read. What you could do is you could copy from the initial CSV file to a TXT file.
Mm-hmm.
Okay.
Mm-hmm.
Here you might be able to locate the problems because the problems are coming from the format.
Mm-hmm.
So if you go here and format it properly,
Mm-hmm. Okay.
the TXT file is always without any format. Can you see what I'm doing?
Yes.
Yeah, so if you do it like this with a tab, then this is the only way you can overcome the regional settings of Excel that usually creates problems when we insert the data.
Okay, we will definitely look at
The other thing is you can get rid of the, for example, you see
Yeah.
this is the problem. Can you see the problem now? For
Yeah,
example,
we had the same issues.
if you have an Excel with regional settings, this number that I'm highlighting is not going to be properly read.
Yeah.
So if I go to 1991, yes, I have only 2 decimal points here.
Mm-hmm.
You probably have more than 2 decimal points.
Mm.
Okay, so I would go to the Google and choose how to change Microsoft Office or Excel regional settings.
Okay. Okay. Thank you. Thank you so much. We will.
Or you can play with the TXT file
Mm-hmm. And do everything manually, kind of.
and do everything manually because the TXT file is the only one that saves numbers without any extra format. Excel is always has an additional format hidden somewhere, unfortunately.
Okay. Yeah. Okay. Thank you so much. We'll try that definitely.
Okay.
Can I add something?
I guess other people might have the same problem, I guess.
Yeah, indeed. May I ask you something related to
Yes.
this? So,
Yes.
just to be clear, in the Excel file, the point is like 6 point something tons of capita. It's like a comma, not for the thousands.
Yes. So Gretel
Okay.
is reading a full stop as a decimal point, not a comma. The comma, you don't want a comma.
Perfect. Thank you.
Okay, so if you have regional Italian settings in your Excel, you might get a comma, and this is creating problems when you read the data.
Thank you.
Okay.
Thank you a lot.
So one thing you can do is copy and paste in TXT in a text editor, and then open the file from the text editor. Or if you have somebody who has UK or US regional settings in Excel, then you should be fine. Other people have similar problems. Other people have similar problems.
I had the same problem of Marcus, and I tried to copy again from the original file.
And did you solve the problem?
I don't know which years I have to delete because there are the years that haven't any data, and I don't know if these I have to delete from the Excel file or not.
Do you want to share your screen so I can have a look?
Yes.
Sorry, what's your name?
Lisa Monari.
Lisa, okay. Now you're a presenter.
Okay.
Okay. So you can start from 1870.
Okay, and I delete this from.
Yes, you should delete all this, and you should keep only the first row. Okay.
And from this year.
No, keep only 1869. Keep only 69. Okay. Delete the other two. 69, please keep it.
Okay. From
So,
68 only.
from 68 onwards, you delete everything. Okay, but keep the first row.
Okay.
Okay. Now, no. Go to the first row. Now, annual. Okay,
Yes,
delete the comma and put underscore between the words and delete. No, here leave it. What says annual? Okay.
This is the underscore between annual CO2 emission.
Yeah, just it's better to find a short name. CO2 underscore emissions underscore PC is enough. Emissions underscore PC. PC is per capita. Okay, delete the parentheses. Okay. Go and do the same thing. GDP underscore PC. Okay, now delete 8069 as well. I thought you didn't have a first row, that's why. Okay. Oh, go further down, let's see what you have. Okay, you have one missing value here.
Yes.
Can you see the link I sent earlier? How to fill?
Yes, before.
Okay, and then you're gonna do this later.
And
then you have
this data.
You have also for this is for the war. Okay.
And from this.
Okay, which country is this?
Austria.
Okay. But the format of your data, okay, you have a problem in 91 onwards. There is a problem with your format over there.
I have to put Excel in English, and I have to do this.
You have to do it from the beginning, yes, because the problem is your Excel is reading files on a complicated format where you won't have some numbers. So the only thing you can do is copy and paste this in a text editor. Okay, make sure that they are aligned, all your data are aligned, and then you include it there. Did you see how I did it earlier, or?
Yes, I saw it. Thank you. I try again.
Let me send you the data again. The best thing if you download it from the web page. Okay, I'll just send you the file again. Okay. Did you got the file?
Yes, thank you.
Any other problems people might have? Any other questions? Any other questions? You want to repeat something about the project?
Yes,
Now,
just to be sure.
if you want to try interpolation, is also available on Gretel as well. Okay, interpolation is also available on Gretel, but it's more complicated. You have to use a console. Yes, Simone, I'm hearing.
Thank you. I managed. I was wondering for the set you put in the chat. Thank you.
You're wondering, sorry, what?
Yes, for the unit of measure of the data, but you put the set in the chat so I can look from it. Thank you.
Yes.
I'm sorry,
Other-
Professor, you told that we can interpolate data also from Excel. Sorry, or also from Gretel.
Yes, but it's more complicated.
Oh, okay.
You have to use the console to do it. I think it's better, you try and do it in Excel where you can see what happens.
Okay,
in Gretel, if you want to try in Gretel, the command, it's called interpol.
Mhm.
The command is called interpol. And you can get Can you see? Can you see?
Yeah.
So you have to open console and use the function interpol.
Okay. And after the bracket?
After the brackets, you need to put the name of the variable. And but as I said, it's better if you do it in Excel so you can see what's going on and then put it in Gretel.
Because I tried to do it in Excel and I can do it for GDP, but
You cannot do it.
I cannot do it for emissions, for CO2 emissions. I don't know why.
Can you send me the Excel file?
Yeah. Can you see it? I did it for.
No, send it to me as an attachment. Send it to me.
Ah, okay. I'll send it in the chat, maybe.
Did you send it?
Yeah. Did you get it?
It's not in the chat. Ah, now it is. Am I sharing my screen right now? Hmm? Can you see my screen?
Yes, I can see it.
You have to delete this,
Okay.
and this should be like this. Now for the step, you need to add, I don't know if you read the file I sent you. So you have to do point. Have you read what I sent you?
Yeah, I was trying to read it before.
0.32 minus 0.42 divided by 1, 2, 3, 4, 5, 6, 7 divided by 8. So you have 0.10 divided by 8. You have to read this carefully though, because now we are doing this yeah, I don't know why this is happening. Now you see, here it's happening, here it's fine.
Yeah, I did it there, but I couldn't do it.
Format cells, number, 2 decimal points. Well, in fact, here you don't need decimal points.
I couldn't do the same thing for emissions.
Yeah, because these are not numbers. Can you see?
Okay.
So let me, this is not a number. Convert to a number. It's the format of the problem, it's not the... So it's the fact that this is not a number.
Mm.
Okay. Now it's working,
Okay.
you see?
Okay, okay.
The problem is that it was not a number. So it's the format of your Excel file that is a problem.
Okay, I understood what the problem was.
Now it's fine.
Okay.
In fact, for these things, I don't want decimal points. Okay, so now you're fine. Okay, but you can see, can you see this blue green thing
Yeah.
on the left? The number in the cell is formatted as text. So you're basically saying to Excel that this is a text file. This is a text, not a number.
Okay.
So this is probably because you have an Italian Excel, I guess. Is your Excel file Italian Excel file?
Yeah, it is Italian.
That's the reason.
Okay.
Okay. Can I close this? Or do
Yeah.
you want me to send you the file?
Yeah, if you could send me the file, it would be it will be set in Italian in my Excel file, so it will be in general and not in numbers, but I can put it in numbers.
I
on
can
my
send
Excel.
it to you, but it's better if you do it. I just send it to you.
Okay, thank you.
Any other questions? Anybody else? If you go to Google and type regional settings, Excel, change regional settings. So it's from the option File, option, regional format settings. Any questions? If there are questions about the project, please let me know. The command log here is you can give direct no, the command log from the console you can give direct direct command. So you can type, for example, help interpolate. Okay. Any questions? You want me to repeat something here? Did I show you how to do the color XY plot? Did I show you how to do the color XY plot? Do you want me to show it again to you? Let me show it to you one more time. Since you're not responding, I'm gonna do it with the logged values. Okay. I chose the logged annual CO2 emissions and the logged GDP. and you can see the colors are the years, and you can see the relationship between the two variables. Okay. Other things you can do if you want to identify outliers is use a box plot. For example, let me use a box plot for the annual CO2 emissions and the logged CO2 emissions and the first differences. I have 3 here. Let me delete this and let me do only a box plot for annual CO2 emissions. Okay, so this is the mean value. In the box, what you get is 95% of your data are here between 5 and 10. And you can use box plots for all your data. Okay. By varied density, is when you get this type of graph. Yeah, this is not very good. Yes, do you want to repeat something here? If you want to get the correlation of 2 variables, I'm going to highlight the variables and you can check the correlation. This is useful if you manage to put more variables on the right-hand side. If you want to check for multicollinearity and you have more than 2 variables on the right-hand side, then the correlation matrix is available from there. The correlation matrix is available from there. Any questions?
Yeah, sorry, we cannot use the correlation matrix for dummy variables and the lagged variables,
No,
right?
no, there's no need.
Okay, thank you.
Only if you manage to find another variable. For example, in the project, I'm asking you as a very generic question, can you improve the model? Which is basically open to you to find something better if you can. And in this case, if you manage to find another variable that's affecting CO2 emissions other than GDP, so GDP is what we call an anthropogenic factor that affects CO2 emissions. There might be other non-anthropogenic variable. If you manage to find something else, then you can check whether there is there's correlation between GDP and this variable you are looking at. Okay. Other questions?
Okay, Professor, in case of non-linear model, should we need to correct the problem of misspecification or if there is autocorrelation problem, then should we have to handle this?
Well, nonlinear model least squares. Okay.
Yes.
So the nonlinear model I have tried in the previous class was this one. This is the nonlinear model I have tried earlier.
Yes.
Correct?
Correct.
Okay, so let me click OK. This is a nonlinear model. For example, let's see this visually. You can see this is a nonlinear model. The model I have estimated is the blue. Is the blue line, the blue spots, and the red ones are the real. So the actual are the red, the fitted are the blue. Okay. So what you are saying, if we have this nonlinear model, you want to test for a Ramsey reset test?
Yes,
Was this
Ramsey
your
reset. If I go for autocorrelation test.
autocorrelation?
Oh, yeah.
Well, here I have UK data. There is clear autocorrelation.
Yes.
In your country,
So,
you might be you might have something else. So how can I? What can I do about this in my model? I can insert a lag of the dependent variable. Maybe I can insert 1 or 2 lags. Okay, so let me try with 1 lag. But this is my case, it's not your case. There's still autocorrelation here with 1 lag. Maybe I can augment the model and put a second lag. Yeah, maybe I can augment the model and I can put the 2 dummies, for instance. If I can put the 2 dummies, there is still autocorrelation. Yeah. So what else can I do? I can put lags of GTP. You have to augment your model a bit. So it looks like I need more lags. I still have autocorrelation here. Yes. So I still have autocorrelation. So what can I do? I can keep on increasing the number of lags. Yes, there's still a correlation. So this is a difficult case because these are not the logs though. This is the linear model. Yeah. I don't know why. I thought last time we solved the autocorrelation problem, but still the p-value is 0 here. So in this case, this is an example. This is an example.
In case of
This is an example that autocorrelation cannot be solved.
yes, in case of non-linear model, we also faced the same problem that we can't easily solve this problem of autocorrelation.
Yeah.
Our data is about Portugal.
Yeah. In this case, you're gonna say that I cannot solve the autocorrelation problem. I cannot solve the autocorrelation problem, and try to do this with the logged values or the first differences. The only way of solving the problem is with first differences. Okay.
Okay. In case of first difference
As I
or
said,
log difference.
sorry, who is this?
I am Ataul Gunasmani.
Okay. Not all problems can be solved. You have to try and see whether you can solve them. You cannot solve all of them.
Okay. Okay, thank you.
Okay. Other questions? And for example, if I do the same for the first differences, now because we've did so many models here, if I do the same with the first difference, you're gonna see that it's very likely that autocorrelation is not going to be present. You see, autocorrelation is not present on the first differences. Did you see that? You see autocorrelation is not present here. You want to repeat something?
No, it's fine.
Any other questions? Any other questions? You want to repeat something? Okay, so let's have a break and we can be back at 4:15. Back at 5:15. Okay, can you hear me? Okay, you can hear me, I guess. Yes, 1, 2, 3. So let's go and talk about time series model now. Is the sound okay? Is the sound okay? Is the sound okay?
Yes, it is.
Okay, so you can see the slides. Okay, so we're going to talk about variables that are operating on the time series dimension. So we're going to talk about time series models in which lagged values of the dependent variable can help us explain and forecast what we're going to do. Okay, so I'm going to start with some very brief definitions that we need later on. The very first definition that we need is the definition of what is a stationary process. A stationary process, y is stationary if it has, I can write this as a constant mean, if it has constant variance, and if it has constant covariance. Okay, so a variable y is stationary if it has a constant mean, if it has a constant variance, if it has a constant covariance. So this is the definition of a weakly stationary process. This is the definition of weakly stationary process. Okay, the second thing that we need to talk about here is that autocovariances depend on the units of measurement of y. Autocovariances depend on the units of measurement of y. Depend on the units of measurement of y. That's why we are usually employing autocorrelations. Autocorrelations are normalized autocovariances where we divide correlation tau s, we divide the covariance, divide by the variance. So autocorrelation are covariances that are normalized, are divided by the variance. So autocovariances are, can I compare the autocovariances of two variables? Covariances. Can we compare covariances? What's the answer? Can we compare covariances? The answer is no, because autocovariance depend on the units of measurement of y. Can I compare autocorrelations? Yes, autocorrelations are comparable. Autocovariances are not comparable. Okay. Autocorrelations are comparable. Autocovariances are not comparable. Okay. So if we take the autocorrelations and plot them, this is called the autocorrelation function or the correlogram. What is the correlogram? The correlogram measures how strong is the memory of a process. Measures how strong is the memory of a process. When we say memory, what do we mean by memory? When we say memory, we mean how strong, how important are past observations for a process, how important are lagged values for a process. Okay, let me go to Gretel. Can you see Gretel here? Can you see Gretel? Can you see Gretel? No? Can you see it?
Yes.
Okay, so if I go to CO2 emissions, right click, the correlogram is here. If I go to right click, the correlogram is here. Okay. So if I click correlogram, how many lags? We can leave the default option here. This is the correlogram. See, this is the first autocorrelation. This is the second autocorrelation, and so on. Okay. In a diagram, this is the first autocorrelation, this is the second, etc. Okay, so one more time, what do we need to say? What do you need to remember from this slide? You need to remember that autocovariances are not comparable. Autocorrelations are comparable. Autocorrelations are obtained when you divide the autocovariance by the variance. Autocovariances take values between -1 and 1. Autocorrelations take values between -1 and 1. Take values between -1 and 1 and measure the dependence between two subsequent observations. They measure the correlation between two subsequent observations. Two observations that are next to each other. Two observations that are next to each other. Okay, so what are the likely values of autocorrelation? Autocorrelation takes values between -1 and 1. Okay. Now, a white noise process is a process with no structure. A white noise process is a random process. Okay, the white noise process has the property of having 0 autocovariances. Okay, a white noise process has 0 autocovariances. Okay, so a white noise process has 0 autocovariance. What does 0 autocovariance means? 0 autocovariance means that what is happening in the past does not affect what is going on now. What is happening in the past does not affect what is happening right now. So the past, 0 autocovariance means that the past does not affect the current value. The past does not affect the current value. Okay, The past does not affect the current value. Why do we need the white noise process? We need the white noise process because it can give us confidence intervals of insignificant autocorrelations. One more time, why do we need the white noise process? We need the white noise process because it can give us confidence interval of insignificant correlation. So the null hypothesis is that the true value of autocorrelation is 0. Now in Gretel, you get the confidence interval from the white noise process automatically. These blue lines around 0. Can you see the two blue lines around 0? These are the confidence intervals from the white noise process. So everything that is inside this blue interval, is not significant. Everything that is outside is significant. Okay, now let me go to the first differences and create correlogram of the first differences. Okay, let me go to the first difference and create a correlogram there. Okay, let me delete that. Now, who is going to help me here? These are the first differences. Is autocorrelation coefficient 1 statistically significant? Is autocorrelation coefficient 1 statistically significant? Is it outside the interval of the white noise process? Is it outside the interval of the white noise process? Is it
Yes.
outside the interval? Okay, is it significant then?
Yes.
It is significant. The second autocorrelation. This is the average correlation between today and 2 days ago. T and T minus 1. Is this statistically significant?
No.
It's not significant. Okay. The third autocorrelation, is it statistically significant?
No.
No. The fourth?
No.
The fifth?
Yes.
Yes. So it's only the first and the fifth that are statistically significant. All the others are not significant. Why? Because inside this interval, you get autocorrelation coefficients that are similar to a white noise process. What is a white noise process? A process, a variable with no structure, a process that is random. A process that has no structure, a process that is random. Okay. Did you get this one? So the white noise process can help us create confidence interval of insignificant autocorrelation. Everything that is inside the blue bound is not significant. Everything that is outside is significant. Everything that is outside is significant. Okay. You want to repeat something here?
Sorry, Professor, can I ask you something?
Whatever you want, yes.
Why are we looking only at the ACF and not the PACF?
Because I haven't talked about the PACF yet.
Okay, so because in the other case there were a lot of differences between the two, so I was wondering just which was
Yeah,
the
we're going to talk about this later on.
Okay,
Do you want me to repeat something about things I've said so far?
No, it was quite clear to me.
Okay. Okay. Now, the second thing we need to do about autocorrelations is to test joint hypothesis test for autocorrelation functions. How can we do this? You can do this with the Q statistic or the Q star statistic. What's the difference between the Q and the Q star? The Q star is used when we have small samples. The Q star is used when we have small samples. The Q star is used when we have small samples. Okay. The Q star in Gretel is given here. Okay. And you get the p-value of the Q star next to it. Okay. Now, let's see an example of an autocorrelation function. Let's assume that you have the first 5 autocorrelation coefficients are tau 1. This is the first one. This is the second, the third, the fourth, and the fifth. Okay. The confidence interval is this one. Who is going to tell me, given the confidence interval, which autocorrelation coefficient is significant? Which autocorrelation coefficient is significant?
The first one, as it is outside.
The first one only the first one is significant. All the others are not significant. Only the first one is significant. All the others are not significant. So when we say the first one is significant, we mean that the relationship between two subsequent points in time, today and yesterday, there is a significant correlation between them. So this, very simple, is telling us that yesterday is affecting today on average. Yesterday is affecting today on average. But what has happened 2 days ago, 3 days ago, 4 days ago, 5 days ago is not important. Is not important in our case. Okay, so what has happened yesterday is important. What has happened the day before yesterday, 2, 3, 4, up to 5 days ago is not important. Okay. Any questions? Anything you want me to repeat? Any questions? Anything you want me to repeat? Now we can also do a joint test with Q and Q star, and we're gonna find that the coefficients are jointly not significant. The coefficients are jointly not significant. Okay, now we're going to talk about the two families of time series models. The first is what we call a moving average model. I'm going to write the simple version of a moving average model. I'm going to write the simplest version of a moving average model. The moving average model says that the variable that I'm investigating, the variable I want to explain, yt, is equals to a constant term, nu is a constant term, plus a coefficient theta 1, lagged value of the error, plus the error. Okay, let's take it one by one. What is mu? Mu is the constant term. Theta 1 is a coefficient that I have to estimate. Ut minus 1 is the lagged value of ut, and this is the error term. Okay, now from this equation I have to estimate mu hat and theta 1 hat. I have to estimate these two. I have to estimate mu and theta 1. I have to estimate mu and theta 1. Okay, I have to estimate mu and theta 1. Okay. Anything you want me to repeat so far? Well, instead of having one lag, we can have more lags than one. You can have more lag than one. So you can have a moving average to model. I'm going to write it here. Moving average to model says that yt depends on a constant term, on one lag, two lags, and the error term. And you can have as many lags as you want. Okay, now ut is a random variable. So ut is a random variable. So what in effect is a moving average model telling us? What is a moving average model telling us? A moving average model is telling us that the variable you're trying to explain, is depends on lagged values of a random variable. Lagged values of a random variable. Okay. Let me show you how we can estimate this. Okay, can you see Gretel? Can you see Gretel?
Yes.
Okay. So you need to go to model and then go to ARIMA. Model, univariate time series, and then ARIMA. Model, univariate time series, and then ARIMA. Model, univariate time series, and then ARIMA. Okay. I'm going to use the annual CO2 emissions. Do you want to keep the dummies here? Autoregressive, I'm going to put 1. And then here I'm going to use two moving average. Oops, sorry. I'm going to use two moving average terms. I'm going to keep the two dummies if you want. I can take it out. Let's take it out and then we're going to add them later on. Okay, so 0 because we haven't done autoregressive models yet. 0 here and moving average 2. Can I click OK? So in your project, we are here, moving average model. Okay. Can I click OK? So this is a moving average to model. This is similar to what I wrote. Look. So my Y variable is the growth rate of CO2 emissions per capita. The growth rate of CO2 emissions per capita. This is new. This is my constant term. This is θ1. Minus 0.38 is θ1. In fact, Gretel is calling this also θ1. And this is θ2. 0.029. Is the constant term statistically significant? 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 Who is going to tell me, is the constant term statistically significant? I need your help.
No.
No, it's not. Is θ1 statistically significant?
Yes.
Yes. At what level of significance?
At
1%.
1%.
Okay. Is θ2 statistically significant?
No.
No. Okay. So let me repeat one more time. What is the moving average telling me? The moving average is telling me that I'm using a lagged random variable. What is the lagged random variable? ut minus 1, ut minus 2, to explain and forecast the growth rate of CO2 emissions. Now, from here, analysis and then forecast, I can forecast CO2 emissions if I want. Okay, let me show you how we can make forecast. In order to forecast CO2 emissions, I have to drop one observation. I have data from 1800 to 2020. Okay, so the first thing I need to do is I need to drop one observation to the last one, and then I will try to forecast this observation. So I need to drop one observation, forecast, and see how good my forecast is. Okay. So one more time, why I'm dropping one observation? I'm dropping one observation because I need to compare my forecast with something. How can I know how good my forecast is? I have to compare it with something. I have to compare it with something. I have to compare it with something. Okay. Any questions?
Can I reduce the starting point?
Sorry? No.
Can I reduce?
The starting point, no, because you want to forecast what is going to happen next year. So what we're going to do is we're going to estimate the model up to 2019, and then you're going to say, I want to forecast what is going to happen in 2020. So you're always forecasting 1 year ahead of the end of your sample. Okay.
Okay.
So I'm going to click OK. I'm going to re-estimate the model. Okay. Now I have re-estimate the model. Oops. Let me re-estimate the model. Now I'm going to re-estimate the model. You see it goes up to 2019. Okay. And then I'm going to use this model to forecast what is going to happen in 2020. Okay. Can I click OK? Okay. So this is my forecast. You can see this is reality and this is my forecast. Let me do it again. Not very good. So it looks like that my forecast is not very good. This is what has happened, and this is my forecast. And this is the confidence interval of my forecast. Okay, and diagrammatically, you can see this is reality, the red line, and my forecast is the red line. Sorry, my forecast is the blue line. Reality is the red one, and the confidence interval is this green interval. You can see that reality is inside my interval, but in the very end of the confidence interval. Okay. Any questions? This is in case you want to make a forecast. Now I'm going to go back to the range and restore the range to 2020. Okay. Any questions? Anything you want me to repeat? So let me repeat the main things. What is a moving average model? A moving average model is a time series model where we're exploiting the lagged values of a random variable in order to forecast in order to explain and forecast the variable that I'm interested in. So I'm going to use ut minus 1. What is ut minus 1? U is a random variable. Ut minus 1 is a lagged value of a dependent variable. Ut minus 1 is a lagged value of a dependent variable that I'm using in order to explain and forecast yt. What is yt? Yt is the variable that I'm interested in. Yt is a variable that I'm interested in. Okay. What do you want me to repeat? What do you want me to repeat here?
Sorry, Professor, probably is, I don't know, you already said that, but the moving average, it's related only to the dependent variable y, right? Not.
Yes.
Okay. And so we can do a comparison only with the data that we have, I mean, for example, here.
You're going to compare the moving average with the autoregressive. I'm going to show you after the break.
Ah, okay. Okay, thank you.
Okay. Any other questions? Okay, let's have a break. Let's have a break for 15 minutes. So let's come back at 6. Okay, so 15 minutes break. Okay, so I guess you can hear me again. So the next thing we're going to do is we're going to talk about an autoregressive process. Now, what is an autoregressive process? An autoregressive process is a process in which the lagged values of the variable itself, are used to explain y. So here we're going to have y equals mu. Let me write again. Y equals mu plus phi 1 yt minus 1 plus ut. This is an autoregressive one process. This is the simplest model, simplest autoregressive model we can use. This is the simplest autoregressive model we can use. So what is yt? Yt is the variable that I'm trying to explain. In our case, this is going to be the growth rate of CO2 emissions. Okay, what is mu? Who is going to help me? What is mu? What is mu?
Constant term.
It's the constant term, very good. What is yt minus 1? This is the lagged value. This is the lagged value of y. Phi 1 needs to be estimated, it's the coefficient, and u is the error. So from this model, I want to estimate mu and phi 1. Okay. Now, obviously, we can have an autoregressive process with two lags. We can have an autoregressive process with two lags. So this would be a model where I'm going to have one lag plus two lags plus the error. Okay, plus the error. Okay, and you can have more lags. Okay. Now, let me write the two basic models here. So we need the two models we're going to concentrate on are the moving average models. The moving average two models. And the simplest case is the moving average one. So the moving average model is this one. And the autoregressive one is this one. Okay, now what's the fundamental difference between the two models? The fundamental difference between the two models is that in the case of a moving average, we are concentrating on lagged values of a random variable, whereas in autoregressive models, we are concentrated on lagged values of the variable itself. So this is the main difference between the two models. In an autoregressive model, the lagged value of the dependent variable is used. In the moving average models, the lagged value of the lagged value of a random variable is used. Okay, so we have a moving average. What are we using to explain YT? A lagged value of a random variable. Autoregressive model, what are we using to explain YT? The lagged value of YT. Okay. Now, let me estimate an autoregressive model here. Okay, we have estimated moving average. Now, model univariate ARIMA. Okay, so I'm going to estimate a moving average one model, similar to what I've written on the slide. So this is a moving average one model. Okay, this is the constant term, mu, and this is theta 1. Okay, and the other model I want to estimate is, I'm going to estimate an autoregressive one model now. I'm going to estimate the autoregressive model 1 now. So I'm going to go to model, univariate time series, and then ARIMA. I'm going to click 1 autoregressive and 0 moving average. Okay, 1 autoregressive, 0 moving average. 1 autoregressive, 0 moving average. And then I would click OK. Okay, so what we have here, we have on the left, you have a moving average model. On the right, you have an autoregressive one model. Okay, so this is an autoregressive model. This is a moving average model. Okay, this is what you need to do in your project as well. Okay, is the constant term in the autoregressive model statistically significant? Is the constant term in the autoregressive model statistically significant?
No.
No. Is phi 1 statistically significant? Yes, it is. Okay. Is the constant term in the moving average statistically significant? No. Is theta 1 statistically significant? Yes, it is. Okay. So I have a moving average model on the left, autoregressive on the right. This is what you need to do in your project here. Okay. So we've done autoregressive, we've done moving average. Now, please note that this type of models, both autoregressive models and moving average models, you can use them when the variable is stationary. So in your case, you should use these two models only only for the growth rate of CO2 emissions. Only for the growth rate of CO2 emissions, you should estimate autoregressive models and moving average models. Only for the growth rate of CO2 emissions, you can estimate, you should estimate autoregressive models and moving average models. Is this clear? You want me to repeat something? So only for the growth rate of CO2 emissions, you need to estimate autoregressive and moving average models. I'm going to skip that, and I'm going to skip this theory. I'm going to go to the partial autocorrelation function. This is what appears in Gretel as partial PACF. Okay, this was the question I was asked earlier. What is PACF? This is the partial autocorrelation function. This is the partial autocorrelation function. And what is this? It measures the correlation between an observation and k periods ago. Once you control everything that is happening in between. So, for instance, at lag 2, tau 2, this is the correlation between t and t minus 2 once you control for t minus 1. Okay, so let me repeat what is the partial autocorrelation function measures. The partial autocorrelation function measures what is happening, the correlation between today and 2 days ago, once I have removed the effect of yesterday. Okay, and let me give you another example. I'm interested in tau 55. What is tau 55? Today is Wednesday. I want to test what is the correlation between today, Wednesday, and last Wednesday, 5 days ago, once I have removed the effect of all the intermediate days. Once I have removed the effect of Tuesday, which is yesterday, Monday, Friday, Thursday. Okay, so this is tau 55 is the relationship between t and t minus 5 once you remove the effect of t minus 1, t minus 2, etc. up to t minus 4. Okay, how can I get partial autocorrelation function? The partial autocorrelation function is given here as a number and here as a graph. Okay, partial autocorrelation function, for example, in the first lag, the autocorrelation and the partial autocorrelation function is always the same. The first point where the two are changing, this autocorrelation, it tells us that on average, as far as the growth rate is concerned, the the autocorrelation between today and 2 days ago is 0.04. This is relatively low. The correlation between today and 2 days ago, once I remove the effect of yesterday, is minus 0.0861. You can see that the partial autocorrelation at the fifth lag is statistically significant. The partial autocorrelation at the fifth lag is statistically significant. This is the correlation between the current year and 5 years ago, once you remove the effect of all the intermediate years, which is 1 lag, 2 lags, 3 lags, 4 lags, and that's it. Okay. Anything you want me to repeat? So this is the partial autocorrelation function. You want to repeat something? Okay, so we've done the partial autocorrelation function, and the last thing we have to do for today is to do the mixed ARIMA models. ARIMA models, they have two constituents, the autoregressive component. This is autoregressive components and moving average components. I'm going to write here the simplest case, which is the ARIMA 1-1. ARMA 1-1. ARMA 1-1 means that this model has one autoregressive component and one moving average component. So this is the autoregressive one. And this is the moving average one. Okay. How can I estimate the mixed ARMA model? Let me go to Gretel. Okay, so I would go to model, univariate time series, and then choose ARIMA. Okay, and then I would go here, I would choose one autoregressive and one moving average. So this is going to give me a mixed autoregressive moving average model. This is going to give me a mixed autoregressive moving average one model. One autoregressive model, one moving average model. Okay, can I click OK? So this is mu, this is the constant term, this is phi 1, it's this coefficient, and this is theta 1, it's this coefficient. Now, which coefficients are statistically significant in this case? Which coefficients are statistically significant in this case? the constant term is not significant. Phi 1 is not significant. Theta 1 is significant at the 10%. You can see that the p-value is below 5%. Okay. Any questions about the AREMA model? Now, when it comes to comparing the models, you can estimate more than one models. You can estimate autoregressive models. You can estimate moving average models, and you can estimate mixed models. When it comes to comparing, you need data from the information criteria. Information criteria is a statistic that allows me to compare competing models. Information criteria allows me to compare competing models. Which model is the best? The best model is the one that minimizes the information criteria. So the best model is the one that minimizes information criteria. Okay. So we're going to use the Akaike information criteria, which is this one. Let me have a look at the three models we have estimated. I have estimated a moving average model. The moving average has a minus 500 Akaike. Okay. The autoregressive model has a minus 498 Akaike. And the ARMA has a minus 498. Which is the most negative out of the three? The moving average, the autoregressive, or the ARMA? Moving average, autoregressive, or the ARMA? The one that minimizes the Akaike information criteria is the best model. Which is the best model in this case?
Moving average model.
It's the best model is this one because this is the most negative Akaike. Okay. Any questions? Anything you want me to repeat? You want to repeat something? Okay. Now let me ask the groups how they're doing. So group number 1 is India, Maria and Carolina. Can Maria and Carolina hear me? Do you have any problems?
Yeah, I can hear you. Not yet.
Have you managed to put everything on Gretel?
Yeah, we have done it yet, so it's all good.
So
okay.
you need to do the linear model, the non-linear model, the log model, the first difference model, the quantile regression model, and the ARIMA model, the autoregression moving average, only for the growth rate of CO2 emissions. Only for this one.
Okay.
Okay.
Yeah.
Is this clear?
Yeah, it's clear. Thank you.
Do you want me to repeat something?
No, No,
Any
no.
problem with the graphs?
No, not yet. Can we, in case, send you an email?
Yeah, it's better if we discuss them here so everybody
Okay.
can benefit. So if you want to share the screen or anything, just let me know.
Okay. Thank you. No, we are
Tomorrow?
okay now.
Tomorrow maybe.
Yeah. Thank you.
Okay, it's a good idea tomorrow because after that, then we're going to then we have the presentations after that.
Yeah. By tomorrow we
Yeah.
will have everything done. Thank you.
Yes, hopefully. Okay. So thank you. Group number 2, Salvatore and Tataul, Portugal. Any problems?
No, till now everything is fine.
Have you managed to do everything?
Yeah, except the autocorrelation problem in the non-linear model that I have asked you previously.
Yeah. Which country do you have?
Portugal.
Portugal. Yes.
Yeah.
You can just say that I've tried to solve this problem, but I didn't manage to solve it.
Yes, of course. Thank
Okay,
you.
like in my case, it was the same.
Okay.
Okay.
Okay, thank you.
Group number 3, Indonesia, Valentina and Carolina. Any problems?
Yeah, I just had a problem with the Excel file, and yeah, now it should be fine. Thank you.
Did you manage to solve it?
Yeah, I put the data on Gretel and now it works, so it's fine.
It works. Okay, that's good. Okay. Group number 5, Hugh. Sorry, group number 4, Job and Maria. Any questions? Group number 4, Job and Maria, they're not listening. Group number 5, Hugh. Is Hugh here? Group number 5, Australia. No. Group number 6, Federico and Daniel. Any problems? Federico and Daniel, no. South Korea, no. Group number 7, Colombia, Sergio and Chiara. Are you listening?
Yes, Professor. No, until now we haven't had any problem. We are missing to do well what we start doing yesterday, but all the graphs that we saw last week, we did it and no problem. We start writing about them.
And the autoregressive models today, you can estimate them as well?
Yeah, no problem.
Yeah. Okay, and you have everything on Gretel. All right, thank you very much. Group number 8, Theodore and Eduardo. Theodore, how are you?
Everything is good so far. I mean, we have to catch up with the last lecture.
You have the same first name as me, so you have to do a very good project, Theodore.
Hopefully, this is why I'm every day here taking notes and trying to do everything.
You're going to be better than me. Okay, this is a promise.
I don't know so, but hopefully.
No, this is a certainty. You're going to be much better than me.
Thank you.
Okay, so any problems so far with Denmark?
No.
Do you have any outliers around the world?
About the outliers, thank you for yesterday, and I have to check furthermore. I mean, for the different models and then for each case. So we are still working on that, and plus we have to catch up with today's lectures and to understand, you know, all the things that you. I mean, to better understand the things that today you explained. But
Okay, so you know how to handle the outliers of the Second World War.
Yeah. Yes. I think so, but we will come back at you. We will work.
Hopefully tomorrow, though. Hopefully tomorrow.
Yes. Yeah. I wanted also to ask you something because all the slots were full for the 13th and the 20th of May. So I
put an extra slot. Yeah, the 6th.
I was wondering, maybe it's too, I don't know, too early. I don't know, the 6th or.
Yeah, if it's too early, you're going to present whatever you have done up to that point, and then I'm going to give you suggestions for how to move forward.
Okay, so it's not related to the final mark what we show on the 6th. It's just to speak.
No.
Okay.
No. But your final mark, you know, given that you are better than me, is also not a secret. Since you're better than me, I can only give you 1 mark. I cannot give you anything else.
Hopefully, I'm touching iron and wood, you know. Okay.
And wood. That's good.
Thank you.
Okay. Thank you, Theodore. Thank you. Group number 9, Benedetta and Giuseppe. Are they hearing me? Any problems? Group number 9, no. Group number 10, Nihat, Singapore.
Yes, can you hear me?
Yes?
I haven't started yet, but I've managed to put my data on Gretel. So
okay,
yeah.
Very good start. And you have followed everything I'm doing so far?
Yes, I have.
And you have the instructions. You don't want me to repeat or help you with something?
For now, I understood everything, I think. But if I have other questions, I'll ask.
You can ask me tomorrow. Okay.
Yeah.
Thank you. Thank you very much. Group number 11, Francesca. Any problems? Group number 11, Francesca. Group number 12, Marco, Germany.
Yes. I already put the data. I done the non-linear one, which I had the 2 dummies due to the Second World War, the quantile, and I also put the lagged one.
The first differences?
And first differences, yeah.
Oh, okay, you've done first difference. And today, the autoregressive models, you can do them as well?
I will do, yeah, I will.
Any problems with what I've done today?
No, not really.
Okay. Very good, Marco. Thank you. Group number 13, Japan, Luca and Andrea. Luca and Andrea, are you here? No, Luca and Andrea cannot hear. Let's go to group 14, Norway, Tatiana.
Yes, everything's fine. I'm doing each step. Till now, don't have any questions.
Everything is okay so far?
Yes.
You don't want me to repeat or clarify something?
No, till now, not because if I don't understand anything, I just listen your lectures again and find the solutions.
Okay.
Thank you.
Thank you very much, Tatiana. Group number 15, Petra and Rebecca. They're doing South Africa. Any problems?
Everything is fine till now.
I can hear a lot of confidence in your voice. Thank you very much. This is Petra, yes?
Yes, it's me. Thank you.
Very nice, confident answer. So you don't need my help. I'm really sad about this, but it's very good for you.
No, maybe
wanted to
later. Maybe
I
later
want
we
to
will
help.
need it.
I wanted to help you, but since you don't need my help, that's very good. So you have your data in Gretel. That's
Yes.
certain.
Yes.
Okay, thank you very much, Petra. Group number 16, Sweden, Pietro and Pietro Simone.
That's all okay until now. Thank you.
With confidence, 100% or less than that?
99.
99. Okay, very good, very good. I'm sad again because you know everything. I cannot help you, but it's okay.
Thank
I
you.
will. Group number 17, Austria, Lisa and Chiara.
We did the file Excel because we did some problem, but now it's okay, and we put it on Gretel during the break, and it worked.
It worked. Okay. How did you solve it? You put through the text editor.
Yes, and there was the format of each number wrong, and I modified it, and then it worked in Gretel, and we have all the observation, because before it was only one observation, because I wronged in to put column and row, that we wrote not only one but more, and I wrong, but now it works.
Very good, very good.
Thank you.
Group number 18, Chiara and Vanya. They're doing Mexico. Any problems? Group number 18, Chiara and Vanya, Mexico, no. Group number 19, Giger and Ruggiero, they're doing Spain. Any problems? Ruggiero can hear us. Marcus, no. Group number 21, Netherlands, Reza and Mehrdad.
Hello. And today I put the data in the Gretel. It worked, hopefully. I will do the project step by step as you expect. If I have a question, I will inform you. Actually, I make a note fully from your lectures, but I have a question about 5 assumptions of linear regression, about 5 assumptions. As you mentioned that the variance of error terms is constant, yeah, but I couldn't find that this process and find a solution for this, because I don't know exactly how can I find the variance of error terms is constant.
If you want to find whether the variance of the error term is constant, you're doing the test of heteroscedasticity. Let me show you. Okay. If you want to see whether the variance of the error term is constant, you're doing heteroscedasticity White test. Okay.
Okay. And how to show that the constant and the variance is a constant?
Well, this is the null hypothesis here is heteroscedasticity not present. Heteroscedasticity means that the variance is not constant. So the p-value here is examining the null hypothesis. So in this case, the variance is not constant because the p-value is 0. So if you want to assess whether the variance of the error term is constant or not, you do the test for heteroscedasticity.
Okay, I got it. Thank you.
Okay. Thank you. Group number 22, Switzerland, Carla and Georgia. Group number 22, Carla and Georgia. No. Group number 24 for Brazil. Ayla.
Everything is fine for now.
You have everything on Gretel? You don't need my help.
Yeah, I have data and I already tried to do linear regression and I'll do other things. So
Okay, so confidence 100%, no problems.
not too much.
Group number 26, China, Rosita and Christina.
We are fine, thank you.
No problems, no problems. Group number 27, Finland, Sofia and Lorp.
Yes, everything is fine till now. We already implemented some of the models and we will ask you if we have some problems in implementing the models that you explained today.
Okay, Ilaria and Eski, Turkey. Any problems?
So far, no, thank you, but we might need your help later. But for now, everything is clear.
Okay, if you have
Thank
questions
you.
tomorrow
Yeah.
you let me know.
Okay, thank you.
Group number 29, Iceland, Federica and Sylvia. Any problems? No, Federica and Sylvia, Iceland, no questions. Group 30, Luxembourg, Sabrina and Isabel. No, Argentina, Ziyafat. Any questions? No, group number 32, Canada, Viola and Filippo. Any questions? Group 32, group 33, Denise and Gizem. Any questions? No. Okay. Okay. So this is fine. If you have any questions, you let me know. That's it for today. I'm gonna see you tomorrow. If you have any questions in the meantime, you let me know. Okay. See you tomorrow. Thank you very much to everybody.
Bye.
Thank you, bye.
Bye-bye to everybody.